The vastness of the universe also changes how we think about probability. Even if the chance of life emerging on any given planet were vanishingly small, the sheer number of planets provides countless opportunities for biology to spark. If one grain of wheat in a field of sand can sprout, then a field made of trillions upon trillions of grains will almost certainly hold more than one stalk. Scientists argue that this statistical inevitability suggests the universe is likely teeming with life. Somewhere, on a distant world warmed by a different sun, organisms may be thriving, evolving, and perhaps even gazing back at their skies with the same questions we ask today. And yet, despite the overwhelming mathematics, we are left with silence. The paradox between probability and experience is haunting. If life should be common, where are the others? Why has no clear signal reached us, no spacecraft landed in our fields, no undeniable trace been found? This contradiction, known as the Fermi paradox, reminds us that numbers alone cannot resolve the mystery. Perhaps life arises often, but seldom develops intelligence. Perhaps civilizations bloom but vanish quickly, extinguished before they can be heard across the stars. Or perhaps we simply lack the tools and patience to detect their presence. What the scale of the universe truly teaches us is humility. The immensity of the cosmos stretches far beyond human comprehension, yet it invites us to consider our place within it. Whether life is rare or abundant, whether neighbors exist or not, the sheer size of the universe ensures that the search is worth continuing. To ponder 10 sextillion stars is to recognize that possibility itself is woven into the fabric of creation. Each pinprick of light may be the stage for a story of life, waiting for us to uncover. And in this realization, we confront both our smallness and our potential in a universe that may be far more alive than we ever dared to believe. For centuries, Mars has been the most alluring of our planetary neighbors. Its reddish glow, visible even to the naked eye, inspired myths of gods and warriors, tales of canals carved by alien hands, and dreams of a world alive with strange civilizations. As telescopes sharpened and spacecraft drew closer, those early fantasies faded, replaced by a new and far more profound mystery. Mars may not be home to bustling cities or towering machines, but it bears scars of an ancient past that hint it was once a planet rich in water, warmth, and perhaps even the chemistry of life itself. The surface of Mars today is cold, arid, and hostile. Temperatures plunge well below freezing, the atmosphere is thin and unbreathable, and radiation from the sun strikes the soil without mercy. Yet this harsh landscape is deceptive. Evidence from orbiters and rovers shows that long ago, the planet was very different. Dry riverbeds snake across its plains, deltas and valleys reveal the unmistakable handiwork of flowing streams, and minerals that can only form in the presence of water are scattered across its surface. Mars, it seems, once possessed vast lakes, rushing rivers, and perhaps even an ocean that covered much of its northern hemisphere. One of the most revealing sights is Gale Crater, a massive basin believed to have held a lake billions of years ago. Here, the Curiosity rover, launched in 2011, has been exploring the layered sediments that line the ancient crater floor. Each layer is like a page in a planetary diary, preserving the conditions that prevailed when water filled the basin. Curiosity's instruments have detected clays, sulfates, and other minerals that suggest long-standing interaction with water. These discoveries paint a picture of a world where lakes endured for millions of years, stable enough to offer a home for microbial life,